Welcome to the video about mass and center of gravity of non-homogeneous lamina. It is an application of multiple intervals. An idealized flat object that is thin enough to be viewed as a two-dimensional plane region is called a lamina. So its thickness is kind of negligible, and a lamina is called homogeneous if its composition is uniform throughout the region and inhomogeneous otherwise. So density of the homogeneous lamina is defined to be the mass per unit area. If we call delta as the density, then the delta is equal to mass by the area. So mass of the lamina is defined by m is equal to the double integral over the region of where delta x and y is the density at the position x, y. If we consider an example where the triangular lamina, so here you can see that it's a triangular lamina, has a density of x into y. So hence the mass is equal to the double integrative of delta xy, that is double integration of xy with dA, where dA is equal to dx dy. And the integration is taken over 0 to 1 and 0 to minus x plus 1. So the after integration you see that 1 by 24 is mass. The center of the gravity of lamina occupying the region R is in the horizontal xy plane is point x bar and y bar, such that the effect of the gravity on the lamina is equivalent to that of the single force acting on the x bar and y bar. So here you can see that's a lamina. So it's balanced on a point, single point. So it means that the whole of the mass of this lamina is concentrated on that point. So that is known as the center of the gravity. So the center of the gravity's formula is x bar is equal to the double integral x into the density divided by the double integral delta x by dA. So similarly, the y bar is equal to double integral y into density divided by double integral the density. So here is another example. So find the center of the gravity of the triangular lamina, and the density is again given by xy. So mass is already defined in the previous question, that is it was 1 by 24. So my is equal to double integration x delta xy dA. So after the integration I will get my is equal to 1 by 16. So mx is equal to double integration y into delta xy dA, and now after integration I will get 1 by 16. So hence the center of the gravity is x bar is equal to 1 by 60 divided by 1 by 24, that is equal to 1 by 25, and y bar equal to 1 by 60 divided by 1 by 24 equal to 2 by 5. The center of the gravity of homogeneous lamina is called centroid. It means that the mass is all uniformly distributed. So also the constant. So hence the delta value is considered to be constant for all regions. So in that time the x bar is only depend upon the value of x and the value of y and the region. So x bar is equal to double integral x dA divided by area of the region, and y bar is equal to double integration y dA divided by area of the region. So in the case of the three-dimensional solid, the center of the gravity is said to be the 1 by divided by m, the mass of the solid is equal to triple integral of delta dV. So x bar is equal to 1 by m, triple integral of x into delta, y bar is equal to 1 by m, triple into y into delta, and z bar is equal to 1 by m, triple integral z into delta. Centroid of the solid is equal to the x bar is equal to 1 by the volume triple integral x dV, y bar is equal to 1 by v, the triple integral by dv, z bar is equal to 1 by v, triple integral z dv. So in the centroid, while we are calling it centroid, in this case the density is considered to be constant for all regions. If you are considering for the semicircular region, for example, say this semicircle with a radius a, And you can see that since it is symmetrical, so hence the x bar is equal to 0. And now just we have to find the value of y bar. Y bar is equal to 1 by area of the region. So obviously the area of the region is half pi a square. So integration y dA, which is equal to, if I convert this integral in the form of a polar coordinate, so we will get this form. So after integration, I will get the answer as 4a by 3 pi. Find the mass of the centroid of the center of gravity of the cylindrical solid, given that the delta y xyz is equal to kz. So here is the cylinder with the height h and the radius is considered to be a. So the mass is equal to integration, so delta dv, so which is equal to kz dz dy dx. So after the integration we will get half kh square pi a square. So z bar is equal to 1 by m triple integral z delta dv. So after integration we will get z bar is equal to 2 by 3h. Since this is a cylindrical form, so x bar and y bar will be taken as a value of 0 because of the symmetry sign. So the only value, the center of mass of the gravity, will lie only on z axis. So hence we found the value of z bar only. Thank you.